Hello everyone, welcome to our channel Python with GecBharuch. Myself Krishna Jadhav. In this series, we will learn about operator and its precedence in Python. In the previous video, we have covered what is operator and two types of operators, that is arithmetic operators and comparison operators. Now, in this video, we will be focusing on logical operators and bitwise operators. So first is logical operators. Logical operators are used to combine conditional statements. It means it is used to perform logical operations on one or more conditions, and these operators are typically used in decision making and control flow statements to combine or invert Boolean expressions. So there is a list of logical operators. First is AND operator. The AND operator returns true only if both conditions are true. Here 5 is greater than 2 and 3 is less than 4. Both are true, so the overall result is true. Second is OR operator. The OR operator returns true if at least one condition is true. In this case, 5 is greater than 2 is true, but 3 is greater than 4 is false. Since one condition is true, the overall result is true. Next, NOT operator. The NOT operator reverses the result of a condition. Here, 5 is greater than 2 is true, but applying NOT makes it false. So now let's switch over to the Google Colab to see how it works. So here, first we will check AND operator. For that we will take A is equals to 5, B is equals to 2, and now we will print A is greater than 2 and B is greater than or equals to 2. So it returns true because here both the conditions are true. Now if we will make one of these conditions false, let's say A is less than 2. So in this first condition A is less than 2 is false, so it returns false because AND operator returns true only if both the conditions are true. Now we will take OR operator. So here we will change A is less than 2 or B is greater than or equals to 2. So here it returns true because OR operator returns true if at least one of the condition is true, and here first condition is false but second condition is true, so that it returns true. Now we will see NOT operator. So we will take A is equals to 5 and print not A is greater than 3. So it returns false because A is greater than 3 means 5 is greater than 3, but NOT operator invert the result, so it makes the result false instead of true. So we have covered logical operators. Now we will go for bitwise operators. Bitwise operators. Bitwise operators are used to perform bitwise calculations on integers. The integers are first converted into binary and then operations are performed on each bit, and the result is then written into decimal format. So they are used to perform operations on binary representation of numbers. These are the bitwise operators. Now first is AND operator. The AND operator performs a bitwise comparison between two numbers. It compares each corresponding pair of bits from the two numbers. If both bits are 1, the result is 1, and if either bit is 0, the result is 0. Next is OR operator. The OR operator also performs a bitwise comparison between two numbers, but the OR operator works slightly different. If at least one of the bit is 1, the result is 1, and if both bits are 0, the result is 0. Next is XOR operator. The XOR operator stands for exclusive OR. It compares each bit of two numbers. If the bits are different, the result is 1, and if the bits are same, the result is 0. Next is NOT operator. The NOT operator is a unary operator. It means it only operates on one number. It inverts all the bits of a number. Ones become 0 and zeros become ones. However, in most systems, the result is given in 2's complement form, which is a way of representing negative numbers in binary. Next is left shift. So the left shift operator shifts the bits of a number to the left by a specified number of place. Each left shift effectively doubles the number for each shift. Next is right shift. The right shift operator shifts the bit of a number to the right by a specified number of a place. So we have understand how bitwise operators work. Now let's see examples on it to get better understanding, and after that we will see some code in Google Colab. First we will see AND operator 5 and 3. So 5 is equals to 101 in binary and 3 is equals to 011 in binary. Now we'll perform AND operation. So 11 is equals to 1, 01 is equals to 0 and 10 is equals to 0. So 001 is equals to 1 in decimal, so that 5 and 3 returns 1 while performing AND operation. Now next is OR operator. So 5 is equals to 101, 3 is equals to 011 in binary. Now 11 is equals to 1, 01 is equals to 1 and 10 is equals to 1. So 111 is equals to 7 in decimal. So 5 or 3 returns 7 while performing OR operation. Next is XOR operation. So 5 is equals to 101 in binary, 3 is equals to 011 in binary. Now performing XOR operation. So 11 is equals to 0, 01 is equals to 1 and 10 is equals to 1. So 110 is equals to 6 in decimal, so that 5 XOR 3 returns 6 while performing XOR operation. Now, NOT operator. So, NOT operator is simply used to invert the bits, that is zeros into ones and ones into zeros. But if we want to check that number is negative or positive, we have to do 2's complement. Here 5 is equals to 0101 in binary. Now we will add 1 in it, that is 11 is equals to 0 and carry 1. 10 is equals to 1, 1 is equals to 1 and 0 is equals to 0. So 0110 is equals to 6 in decimal. Now we will check that 6 is negative or positive. For that we will take 0101, that is 5 in binary. Now we will invert it, that is 1010. So this first bit 1 is indicate that 6 is negative, so that not 5 is equals to minus 6. Now left shift operator, 5 left shift by 2. So 5 is equals to 101 in binary. Now we will shift it by first bit. So 101 is equals to 1010. We'll add 0 at last. Now by shifting second bit 10100, we'll add second 0 at last. So these two zeros are added by 2 bit shifting. So 101 is equals to 5, and by 2 bit shifting 10100 is equals to 20 in decimal. So that 5 left shift 2 is equals to 20 while performing left shift operator. Next is right shift operator, 5 right shift 2. So 5 is equals to 101. Now we will right shift it. So 010 by shifting first bit, and by shifting second bit it will 001. So 5 is equals to 101, and by shifting 2 bit it will become 001. So 001 is equals to 1 in decimal, so that 5 right shift 2 is equals to 1 while performing right shift operator. So we have seen examples. Now we will see it by running some code examples. So first we will take A is equals to 5 and B is equals to 3. Now we will print A and B, comma A and B. Same, we will print A or B, comma A or B. Same, we will print A XOR B, comma A XOR B. Now we will check the output. So A and B, 5 and B 5 and 3 returns 1, 5 or 3 returns 7, and 5 XOR 3 returns 6. Now we will see not operator. For that we will print not A, colon not A. So it will returns -6. Now we'll see left shift and right shift. For that we'll take A is equals to 5 and B is equals to 2. Now we'll print A left shift B, comma A left shift B, and then we'll print A right shift B, comma A right shift B. So it will returns 5 left shift 2 is equals to 20 and 5 right shift 2 is equals to 1. Thank you for watching this video. I hope this video helped you to understand logical and bitwise operators in Python. The lecture notes for this series are available in the description below. Make sure to check them out. Other types of operators will be covered in next video, so stay tuned, and until then, don't forget to like, share and subscribe for more such content. Thank you.